We are going to discuss about 14th group elements. So in this group, these are the elements: carbon, silicon, germanium, tin, lead. So tin also called as stannous, lead is plumbum, T half of C14 5770 years. So this is the atomic radii order. For that, mnemonics is cute, smart, gents or girls or geeks, slowly plump. And this is ionization energy order. For this, mnemonics is cold sun gets softness and powerful. Electronegativity order: carbon powerful, next lead remaining same. So bond energy order also decides catenation property. So bond energy order is CC bond greater than SI bond greater than remaining 2, and here catenation property self-linking capacity. So this is the order: carbon greater than, silicon greater than, germanium greater than tin, and PB doesn't show catenation property, very important point. Next one, inert pair effect. So atomic valency configuration of 14th group elements is ns2 np2. Here total 4 electrons in its outermost shell. So s electron doesn't participate in chemical bonding, only p electrons participate in chemical bonding, so that +2 oxidation state is stable for the last element of group is called as inert pair effect. So generally pb is last element, so it is stable with +2 oxidation state than sn than germanium. And SiF6, these compounds doesn't form. Very important question: which compounds are known, which compounds are unknown? SiF6 -2 and GeCl6 -2, SnOH taken 6 -2, PbOH taken 6 -2. So these compounds are known. SiCl6 -2 doesn't know because of bigger or high atomic size of Cl atom. Nature of oxides. So these are the oxidation nature of oxides. CO is neutral oxide, CO to SiO to GeO to are acidic oxides, SnO PbO amphoteric, GeO are distinctly acidic. So here very important: tin and lead oxides only amphoteric, remaining all are acidic, and CO is neutral. Here there will be no basic oxide. That is important point. And coming to some of the important points from halides. So all MX4 type are covalent in nature except SnF4, PbF4, those are ionic in nature. PbI4 doesn't exist, and CCl4 doesn't undergo hydrolysis due to absence of d orbitals, because valence shell of carbon doesn't have d orbitals, so there will be no nucleophilic substitution reaction. So carbon make p-pi bonds with itself and with other atoms. So that's why carbon have more bond strength as well as more catenation property. And silicones is the next important topic in this. So R2SiO taken n times. Here R is nothing but alkyl or aryl group. So over hydrolysis we can make a different type of silicones. So SiCl2 plus H2 gives rise to OH twice. Further heating loses water and get cyclic or linear silicones, which means R will be like this: R, Si, R, OH, OH, and another same type of silicone, OH and OH. So here loss of water happens. Here this with other molecule also loss of water. Like that, this side also other molecule loss of water. That's how the cyclic or linear silicones are formed. To get linear, 2 OH groups should be in every monomer unit of silicon. That's how this will happen. Suppose if you take only one Cl, then only one OH is formed, then we get only dimer. Means only one condensed bond is formed by loss of one water molecule. Coming to next, R SiCl. Suppose with 2, what happens? Sorry, with 3. With 3, OH thrice will be formed, because in this case all the 3 sides the further links will happen. So this is, suppose if you take R and this side OH, then what happens? This side one linear polymer, this side one, this side one. That means all our cross-linked polymers are formed. So coming to next topic, columns. So M2SO4, two metal salts combines with 24 water molecules. So in this case, first metal oxidation state +1, second metal oxidation state +3. Those are called as alums. That is the general formula. And more salt, potash alum, those are the examples for this. So K2SO4, Al2SO4 taken thrice on 24H2. But in this case, +2 and +3 of metals. Suppose if any alum is formed with this, not alum, if any double salts combined with +2 and +3 oxidation state, then that is called as pseudo alum. So pseudo alums means false alums. Coming to boric acid, this is not required here. Silicates, SiO4 4-. So based on the number of SiO4 units, we can define or we can see the types of silicates. Orthosilicate, these are the examples: zircon, phosphorite, so wilmate. So in this case only single SiO4 4- units are connected. Pyrosilicates means 2 SiO4 units connected with oxygen atom. So that is sharing between 2 SiO4 units, as like this. Like this. That means these 2 silicate units joined with one sharing atoms. and in this case silicon connected with 4 bonds like this. Similarly, cyclic silicates, 2 oxygen atoms are shared. In this case, these are the general examples. SiO3 2 minus, SiO3 2 here 2 atoms are sharing, so that minus 2n. Example of this. And chain silicates, simple. These chain silicates subdivided into 2 types, simple and complex. Forms of carbon students: diamond, graphite, fullerenes. So C60 or C70 it will come. So this how the carbon bonded with other carbon, that is in 3D network solid, like all the 3-dimensional wise the carbon bonds are located. It is layered structure, and these layers are joined through van der Waals forces, and graphite over heating will get fullerenes. So this is Buckminster fullerene, it will be C60 or C70, and hybridization of every carbon in this sp3, here sp2, here also sp2 hybridized, and carbons are joined through covalent bonds. And non-aromatic, it is aromatic, it follows all the aromatic rules like 4n plus 2 pi electron rule and planarity, ring form, all these things. sp2 hybridized, very important. Here also hybridization is sp2. Here dazzling bonds are present, which means insufficient or incomplete valency of carbon, means every carbon doesn't have 4 bonds. So here also dazzling bonds are present, insufficient valency, so there will be no dazzling bonds in this. It's a good conductor, good thermal conductor, but not electrical conductivity. Very important, this question came in advanced exam once. Good conductor of heat and electricity, very important, known point. So good thermal and electrical conductor, this one. How the bonds are located, and C60. So 5-member ring connects with 6-member ring, and 6-member ring connects with only 6-member ring. So here 6-member ring connecting with both 5-member rings as well as 6-member ring, but 5-member ring connecting only with 6-member ring, and these are very important point. How many 6-member rings are present? 20. How many 5-member rings are present? 12. So 5 is less, even number of rings also less, remember like that. And this is rugby ball shape, and C60 will be soccer ball shape. And these are joining as like this. Everywhere carbon is connecting with the 3 bonds in graphite, so that that extra mobile electron is responsible for conductivity and lubricant and soft and slippery. And this is hard substance on the earth, and thermodynamically more stable form of carbon is graphite, then C60, then diamond. This is the order of stability thermodynamically. While formation of graphite, it loses some amount of energy which is more than the diamond. Thank you, bye.